Alright, now we go to fundamental problem 13.5. So basically you have an assembly of two members here, AB, BC, AB and AC, right? And basically for this assembly with this kind of 1.2 meter for AC, and the line between B and C, point B and point C is 0.9 meter, and one vertical load P downwards is applied to joint A. Alright, and these members are made from 86 steel, and the diameter is 50 millimeter, and the question asks you to use factor of safety of 2 against buckling. Alright, so the question asks you to find what is the maximum P that can be supported by assembly without causing the AC to buckle. Alright, so what is the idea? The idea is, because the question asks you not for AC not to buckle, right? So you need to find what is the critical buckling of AC, and then you try to relate with this P to find what is the maximum P that will cause. Maximum P with for AC not to buckle. Alright, so you can start with either starting from follow diagram, or you can start from the finding critical buckling load. Doesn't matter. But here I want to start with this free body diagram, right? At joint A, what you have at joint A? At joint A, you have P, right? Which is the applied load P, and you have member AB and member AC. So basically you have this FAB, right, going up, and the horizontal force of FAC, which you want to find, right? What is the direction of FAB? This is 0.9, this is 1.2. So you can find, you can use this theta equals to arctangent of 0.9 over 1.2. But here actually I want to draw your attention to this one, which is 3, 4, 5. Alright, how do you know it is 3, 4, and 5? 3, 4, and 5, the ratio, right? Because it will be 0.9, 1.2, and then this one will be 1 point. How much? 1.4. 1.5, right? This one will be 1.5. So the ratio is 3, 4, and 5. Okay? Even this ratio inside is 3 and 4, so it is 3, 4, and 5. Right? So if you solve Fx equal to 0, so you will have your 4 over 5 FAB equals to, sorry, not F. You solve F, not Fx, Fy first. Fy equals to 0, so you will have your 3 over 5 FAB minus P equals to 0. So your FAB in terms of P is 5P over 3. Okay. And then you do Fx equal to 0, so you will have your FAB, which is 4 over 5 FAB, right? 4 over 5 FAB minus FAC equals to 0. So your FAC in terms of P, which is the most important thing here, is how much? 4 over 5 FAB, which is 5P over 3, right? Which is how much? 20P. Sorry, 4 over 5. So okay, 4 over 3. 4P over 3. Alright, so FAC, okay, force AC, which is in this case what? Tension or compression? It is a compressive force, right, going inside. So FAC, the compressive force of FAC is, in terms of P, is 4P over 3. Right? So now we go to, now we know what happened here is, for this member AC, right? For this member AC, with this diameter of 50 millimeter, you have the compressive force of how much? This one, FAC, for P over 3, right? For P over 3. Right. So you want to find what is the critical buckling load. I mean, you want to find P, but on the maximum P that you can apply not to allow AC to buckle. Alright, so you need to find what is the critical buckling load of this FAC. So now we're done with this relation. What's the critical buckling load of FAC? Of AC, sorry, remember AC. Critical buckling load of AC. It is pi squared, again, EI over KL squared. In this case, pi squared E is how much? E is for 86 steel is 200 gigapascal, right? I for it is what? this is a, because it has a diameter, right? So this is a circular cross section, isn't it? So the I is pi over 4 times c power 4. C is the radius, which is 25. So okay, power 4 c power 4, c power 4, which is 25 power 4. Okay, pi over 4 times c, which is 25, which is the radius, over 4, right? Over k. What is k here? K, so that this is pin and pin, right? So k is 1. Right? What is the L? L is the length, total length, okay, of AC, which is 1200 millimeter. Alright? I'm working on this non-SI unit, so if you are unsure, change everything to SI. So your critical buckling load for AC column is, if you calculate this, you will get your critical buckling load as 420.55 kilonewton. Right? Okay. Now, this is actually FAC, isn't it? The only difference is that this is general relation between FAC and P, right? Applied load P, while this is the maximum FAC, which can be supported not to buckle, isn't it? So we put it here, P critical, sorry, these values, right? Oh, okay, before that, forgot. Though actually you have this P critical, we talk about the factor safety, right? Factor of safety of 2 against buckling. So you need to use this factor of safety of 2, which is defined here as P critical, okay, this load over allowable. Alright, so the one that you want to use is allowable, not the P critical itself. Okay, because you don't want to use this value, because it will be, you want to put some safety measure, right? So you use the factor of safety. So now your allowable load is P critical 420.55 divided by factor of safety of 2, which is actually half of this critical load, right? So your critical load is half to be, the allowable load is half, which is 2.5, I think. Yes. 2.7. Right? Can you see that? Because you use factor of safety of 2, now you allow the load, the maximum load, to be applied only half of the critical load, right? Okay, let's go back up there. Right. Now we want to find what is the maximum P that can be applied, right? So you use this, okay, this P allowed against the FAC. So it is for P maximum or allowable over 3, right? FAC, and this is FAC of allowable, which is 210.27. So your P max is, you solve this, you will get 157.7 kilonewton. Alright. Okay, how to interpret this? If you apply 157.7 kilonewton P at this joint A, right, vertically, the compressive force of 210.27 kilonewton will be applied to the column member AC. Alright, column member AC. And this one is actually, with the factor of safety of 2, it is half of the critical buckling load of this column itself. Right? Okay, just one more thing. If you want to check this, if you want to check, where is the critical buckling? Okay, this one. This critical buckling load, alright, against the yield strength, you can do that. So it will be the same like your problem 13.1, where you check this one, you find the critical buckling stress, and then you compare with your the yield strength of the material, right? Because you know that this is A36 steel, right? So the yield strength is 250 megapascal, and you can check which one occurs first, whether this one or the yield strength. Okay.